Number 1 says, which of the following graphs would not represent the relative frequencies of heads when tossing 1 penny, and explain your answer. So when we toss a head 1 time, we either get 1 head out of the total tosses, or we get no heads out of the total tosses. This one has a probability of 0.0, and this one has 1.0. So we either start at the very top of our graph or the very bottom of our graph, but we can't start in the middle. So which one is not representing tossing 1 penny? Graph A does not represent the frequency, meaning the probability for that event of tossing 1 penny. You can't start at 1/2 because you have only tossed 1 time. You can't have 2 tosses on the bottom as your total because you've only tossed it once. Jerry indicated that after tossing a penny 30 times, the relative frequency of heads was 0.47. He indicated that after 31 times, the frequency of heads was 0.55. Are his summaries correct? Why or why not? So for number 2, if you toss it 30 times and get a decimal of 0.47, we've got to figure out how many tosses landed on heads. And then if you do 31, can it be 1 more and come out to 0.55? So we can work backwards and do a cross multiply and divide. These decimals are always out of 1. That's always what numbers are out of. Unless we're talking about percents, then we put it out of 100. Which I guess you could do as well, but you would want it to say 47 out of 100 instead of 0.47. So if we cross multiply and divide, we should get. And if we cross multiply and divide here, what would we get? So that first one, it comes out to 14.1, and the reason why it's not exactly 14 is because they've rounded this answer here. So we're going to say that this is just 14. Then on the second one, if we did 31 times 0.55, it comes to about 17 heads out of 31 heads. Is it possible to flip the coin only once more and get 3 extra heads if we only toss the coin once? So you should either have 14 heads here and 15 if you got a head, or if you got a tails, it would be 14. But we can't get 17 heads if we've only tossed the coin once more. So when it says, is he correct? No, because he could only have 14 out of 31 or 15 out of 31. Neither are equal to 0.55. In number 3, it says Jerry observed 5 heads out of 100 tosses. And it asks, do you think this is a fair coin? Why or why not? I would say no. A fair coin should land on heads. (50 out of 100 times. half of the time. So this is not a fair coin because this is only 5 out of 100 and not 50 out of 100. And you can put your explanation in your own words, or you can modify what I have here. You might even say that this is 0.05 and we expect this one to be 0.50. It's up to you how you phrase it.